Question 6. If the integral from 1 to 2 of 4 plus ln x is approximated by a midpoint Riemann sum with 4 subintervals of equal length, then the value is equal to what? Alrighty, we've got a midpoint Riemann sum going on here, and we have 4 subintervals. So I'm going to start out by making a chart. I need to get from 1 to 2. 2 minus 1 is equal to 1. I need to split it into 4 parts, so I'm going to be going by 1/4 or 0.25s. So I'm going to have 1.25, 1.5, and 1.75. Okay, so since I'm going by equal intervals, I can put what I'm going by on the outside, so I'm going by 1/4. And then the inside, we need to do a midpoint Riemann sum. So in the first one, from 1 to 1.25, in between those two, halfway in between those two is going to be 1.125. So I'm actually going to find my function at 1.125 and then plus, and I'm going to call this, we'll let that equal f of x. The next one, I'm going to have the halfway between 1.25 and 1.5 is 1.375, and then plus halfway between 1.5 and 1.75 is 1.625, and then halfway between 1.75 and 2 is 1.875. Okay, and now we can let our calculator do the work on this one, and if we let our calculator do all the work on that one, we should get 4.388 as my answer. Okay, one comment if you weren't sure where I was getting those values from, if you just took the average, so do 1 plus 1.25 and then divided by 2, you can get the 1.125. So I believe that's it. Okay, question 7. Find the limit as x approaches infinity of e to the x over the natural log of 1 over x. So basically, if I'm going to let x approach infinity, I get to use my calculator. I basically want to know what's going to be happening as my x value gets bigger and bigger and bigger. So what I chose to do on this one was to graph it, and then I'm going to use the table feature of my calculator to help me out. Okay, so if you graph that in your calculator, and when you graph it in your calculator, I found that it was a very misleading looking graph. When I first graphed it, it looked something, I think it kind of looked something like that, but I found out that that actually did not give me anywhere near the right answer, and it just had to do with something that I was zooming. So if you wanted to use the graph, we should do zoom fit on it, but that's not the approach that I took anyway. So when I plugged this into my calculator, you just type it in as e to the x over ln of 1 over x. What I did, when I did my table feature, I just found, I made some values for x getting bigger and bigger. I started with x equals 10, and then x equals 100, and then x equals, I was going to do 1,000. When I typed in 10, I got negative 9,566. When I plugged in 100, I got negative 6e to the 42, and that means negative 6 times 10 to the 42 power, which is actually negative 6 with 42 zeros on it. So it's a huge negative number. When I tried 1,000, I got an error because I guess that was just too big. So I tried 200 instead, because again, I just want x to get bigger and bigger. When I did that, I got negative 1 times 10 to the 86, which means that's negative 1 with 86 zeros. So that's a lot of zeros. So that's an even bigger negative number. Anything after 200, I tried, it was just too big. So I noticed that my y values are getting larger and larger in the negative direction. So my limit is going to be negative infinity. Okay, number 8. The equation for the horizontal asymptote for the function f of x equals this big thing is what? Okay, horizontal asymptote. To find this, we're going to find the limit as x approaches infinity or negative infinity. So that's how we find a horizontal asymptote. And if I'm going to find the limit as x approaches infinity of this function up here, we want to compare the degrees in the numerator and denominator. We did this on a previous day's assignment. Okay, so we want to compare the degrees in the numerator and the denominator. I remember I'm only given like 2 or 3 minutes to work on the problem. So if I had to expand this all out to figure out the degrees, it's going to take me a while. So what I did instead, I kind of cheated a little bit. I looked at, okay, the highest power in this part of the parentheses is 2x, the highest part of the power in the parentheses is 3x, and then for this one, this is going to be x to the fourth. And so I basically on the top have 2x times 3x times x to the fourth, which gives me 6x to the sixth. Okay, and then down on the bottom, if I were to FOIL that out, my highest power is going to be x to the sixth. And so I notice that the degrees are the same, and if the degrees are the same, we take the ratio of the leading coefficients, and this one would be a 1. So if I take 6 divided by 1, my limit is 6, and if my limit is 6, then my horizontal asymptote will be y equals 6, which is choice D. Notice how much faster that was than actually figuring it all out. Okay, number 9, if the big F of x is equal to the integral of 2x cubed plus 8 and f of 4 equals 6, then f of 1 equals question mark. Okay, I noticed that they're telling me that big F is the answer to this, so I can write the integral of 2x cubed plus 8, and I know that's going to equal big F because they told me that it was going to equal big F. And I do notice that they give me two x values, so I can actually put those x values right on my thing, and I can do brackets. It's going to be evaluated at 4 and 1, and so that will equal f of 4 minus f of 1. And now from here, to get this answer, we can just use Math 9 since it is a calculator problem. So if I use Math 9 on that problem, I will get 19.921, and then it's going to equal f of 4 minus f of 1. They told me that f of 4 was 6, so I'm going to have 19.921 equals 6 minus f of 1. Then I'm going to subtract 6 from both sides, so I'll get 13.921 is equal to negative f of 1. And then if I just multiply both sides by negative 1, I'll get f of 1 equals negative 13.921. So B will be my answer. Okay, number 10, find the value of C guaranteed by the mean value theorem for f of x equals e to the x minus x on the interval -2 to +2. Okay, mean value theorem. Basically the mean value theorem states that at some point the derivative will equal the slope. So step 1, find the derivative. Okay, to get the derivative, we'll do f prime equals the derivative of e to the x is e to the x minus the derivative of x is 1. So step 1 is done. Step 2, we're going to find the slope. Okay, to find the slope, we need 2 points. So it's going to be -2 something and 2 something. Right, so when I plug -2, and basically to get these y values, we're going to plug them into the original equation. So if I plug those into the original equation, if I plug -2 in here, I'm going to get e to the -2 minus 2. And then if I plug 2 into the original equation, whoops, this would be minus -2, which will be +2. And then this will be e to the 2 minus 2. Okay, now to get the slope, it's y2 minus y1 over x2 minus x1. So the slope will equal e to the 2 minus 2 minus e to the -2 plus 2. Notice that I did put that in parentheses, all over 2 minus -2. Okay, so I'm going to get rid of my parentheses. Now I'll have e to the 2 minus 2 minus e to the -2 minus 2, and that will be all over 4. And then if I combine like terms, I'll get e to the 2 minus e to the -2 minus 4 all over 4. And then from here, I actually got that as a decimal. And when I got that as a decimal, that turned out to be 0.81343. So that was the slope. And then the third step is we want to take the derivative and set it equal to the slope. Woo. Oh goodness, let's go back to my problem that I want. Okay, equals the slope. So the derivative is e to the x minus 1, and I'm going to set it equal to the slope, which is 0.81343. And then I'm going to add 1 to both sides. So e to the x will equal 1.81343. Then to remember to get rid of the e to the x, we'll take the natural log of both sides. So we'll get x ln e equals the natural log of 1.81343. ln e, of course, is 1, so we're just going to get x equals the natural log of 1.81343, which is 0.595. So I found that value, and it was 0.595.